Dear students, yesterday we discussed about the local maxima and the local minima of a function. Which point in the domain is called as a local maxima and the local minima. Now today I will explain you the geometrically these 2 points. Now let's assume that this point C in the domain is the local maxima. That is, at that point the f of C is greater or equals to f of x for all x belongs to in the neighborhood. Now neighborhood Now, if we consider the points in the neighborhood of C but from the left side, that is for all x in C minus delta to C, f of x is here increasing because when it is local maxima, that is derivative is positive. While as in C to C plus delta means in the neighborhood of C but from the right side of C, f of x becomes decreasing function and is decreasing function, that is its derivative is negative, which implies that at x equals to C it changes behavior from increasing to decreasing, which implies that at x equals to C derivative must be 0, that is f dash of C equals to 0. Similarly, if it is local minima, that is at C local minimum value exists means f of C is the local minimum value. This means that in the neighborhood of C but from the right and this left side, that is in C minus delta to C for all x's, f of x is decreasing function means derivative is negative, while as in C to C plus delta means in the positive neighborhood of the C, that is for all the points which are slightly greater than C, f of x is increasing function means f dash of x is greater than 0. This means that at C it changes behavior. It suggests that the derivative should be 0, must be 0 at x equals to C. From this we conclude that if C is the local minima or the local maxima of a point, that is at point C the local maximum and the local minimum value of the function exists, then derivative is 0 or derivative does not exist. Because if we consider the last days example in which we study the maximum and minimum value of this graphically, the maximum and the minimum value of the modulus function, minimum value exists at x equals to 0, but at x equals to 0 modulus function is not differentiable. This means that if C is the point of local maxima or the local minima, then its derivative at C is 0 or its derivative does not exist at point C. Now what about converse? Now if we consider, that is converse means that if f dash of C is 0, does it imply that this C is the C is the local extremum, that is C a local minima or the local maxima? For this we consider an example f from R to R. Its derivative is given by x cube means at x equals to 0 derivative is 0. This means that x equals to 0 is the critical point, but its maximum, this minimum value does not exist at x equals to 0, because there exists points below the 0, that is from the negative side of 0, at which the value exists means at which the value is less than the value of the function at 0. This means that x equals to 0 is not the local minima, although derivative is 0. In this regard we have the this one of the important test which gives us the under what conditions this f dash of C equals to 0 implies that C is the maxima or C is the local minima. So let us define this first derivative test. Now if we have a function which is defined on open interval I and such that it is continuous at the critical point means where derivative is 0, means let's assume that f dash of C equals to 0 and this function is continuous at x equals to C. Now first postulate of this test is if f dash of x changes sign from positive to negative as x approaches through C or as x approaches increases through C, that is for all the points which are less than C derivative is positive, and for all those points which are greater than C derivative is negative. This means that it changes sign from positive to negative as x increases through C, then C is the point of local maxima. Local maximum means maximum value exists at C. Like if we consider here at C derivative is 0, here in the left portion of this graph, derivative is 0, derivative is 0 for all the points which are less than c, that is in this portion. This f dash of x is positive, means because it is increasing, while as in this it is decreasing function, that is it changes sign from positive to negative, which implies that f of c is the local maximum value, while as c is the local maxima. Similarly, second postulate of this theorem states that if it changes, means derivative changes from negative to positive, as x increases through c, that is if f dash of x is less than 0 for all the points which are less than c, and f dash of x is 0 greater than 0 for all the points which are greater than c, then c is the point of local minima. Like if we consider here, for all the points which are less than c, that is in this portion, derivative is negative, while for all the points which are greater than c, derivative is positive, which implies that c is the local minima and f of c is the local minimum value. Now if it does not change the sign as x increases through c, that is if this remains constant, that is, it does not change the sign from positive to negative or from negative to positive, then this is not the local extremum, or simply we say that this point c is called, when it does not change the sign, it is simply called as the point of inflection. Let me consider example to find all the points of local maxima and the local minima. Like if we consider f of x equals to x cube minus 3x plus 3, its derivative is 3 into x minus 1 into x plus 1. That is, at x equals to 1 or x equals to minus 1, f dash of x is 0 because it is quadratic, it has two roots, means critical points are x equals to 1 and x equals to minus 1. Now at x equals to 1, now we will consider the points, we will increase this x through 1, that is we will take firstly the points which are less than 1, that is in interval 1 minus delta to delta this 1. This is negative term because here x is less than 1, means x minus 1 is negative, while as x plus 1 is positive, which implies that positive into negative is negative, hence derivative is negative, that is f dash of x is negative for all the points which are less than 1, while as if x if we take the points which are greater than 1, that is in interval 1 to 1 plus delta, that is x greater than 1, this means whole this term x minus 1 is positive because x is greater than 1, while as x plus 1 is clearly it is positive, which implies that positive into positive is positive, hence f dash of x for all the x's which are greater than 1 is positive. This means that it changes sign from negative to positive and as we increase x through 1. This means that x equals to 1 by first derivative test is local minima, and the local minimum value is obtained by replacing x equals to 1 in given function, which is 1. Hence 1 equals to local maxima as well as 1 equals to the local minimum value. Now at x equals to 1, now we will increase x through minus 1, that is firstly check the behavior of this derivative for all the points which are less than 1, which implies that derivative is 3 into x minus 1 into x plus 1, and for if x is less than 1, means these two terms containing x are negative, which implies that their product is positive, hence overall change is positive. Similarly, if x is greater than minus 1, one term is negative here, that is this term is negative, whereas this term is positive, implies that their product is negative, that is f dash of x changes sign from positive to negative. This means that this x equals to minus 1 is the point of local maxima, and the maximum value or the local maximum value of f of x is by replacing x equals to 1 in the given function, which is 5. So 5 is the local maxima value which is attained at x equals to minus 1, while as x equals to 1 is the local minima, and the local minimum value of this function is 1. So this was about the first derivative test. Now for point of inflection, we will check now if it does not change its sign from positive to negative or from negative to positive. What can we say about this point? Is this the point of the local maxima or the local minima? In this regard, we have another test that is called as the second derivative test. So inshallah in tomorrow's video lecture we will discuss this second derivative test. So thank you.